Been having a challenging demo day, so we will see how far we get. Let me try and get this up on the screen. It looks like I cannot get network connectivity over to my device, so I'm going to enable serial port, if we can get that to work. So apologies. So how many people here are involved in IoT today? Oh wow! All right, that's fantastic. Hopefully, I've got something good to show you. We've been working in Visual Studio on bringing some developer tools up for IoT. How many of you are aware that we released an extension for GDB support for Visual Studio last year? Cool. So just a couple. So that's actually what I'm going to talk about today. One of the things I'm going to talk about today. If I can get this up on the screen. All right. So what we're trying to do is we're trying to bring up tooling within Visual Studio to help people connect to Azure IoT. Or how many people are aware that Azure IoT has a solution, or that Azure has an IoT solution out there? Oh wow, really? So they do. And so what we're trying to do is bring some tooling up in order to support them. They have, basically what Azure IoT has got is a set of solutions for things like predictive maintenance, where they have services that you can deploy like an end-to-end solution within Azure. So it's an entire solution that gets deployed out, and then you've got resources for both deploying and managing the services, as well as some device capabilities that they've got. And as part of that, they've also built out an entire platform so that you can actually, you can design your own solution on top of this, right? So what they've got is there something I can do for the video here? Which source it is? Okay. I should have been spending all that time with the video equipment, not my equipment.
This guy's pretty helpful.
It says, what is this?
There it is.
All right, there we go. Okay. All right, fantastic. So yeah, I did not bring slides because I kind of wanted to just kind of go through what we've got and help you find some of this stuff. So if you just search for Visual Studio GDB, one of the first things you'll find is this extension that I was talking about. We've got a great connection here. Wow. Very interesting. Well, let's try connecting that. All right, so we've got this extension here for Visual Studio that enables GDB. What this does is it enables, there's a capability within Visual Studio called the MI engine for machine interface. So when Visual Studio introduced support for Android tools, how many people here know that we have Android support within Visual Studio? Awesome. So we take a dependency on that for this tooling. When they developed the debugging capability for the Android tooling for the C++ side of that, what they did was they actually implemented it generically as a machine interface rather than specifically for the Android debugger. And so through that, they were then able to leverage that again for some of the iOS debugging, including with LLDB. The MI engine is open source. It's actually out on GitHub. sometimes you can look there and see what we're doing. Yeah, so this is it up there on GitHub. And so they've actually done some work where they've even pushed changes back to LLDB in order to improve the MI, the machine interface support within LLDB, so that they can actually bind to that. And so what we did with this GDB debugger was we basically went more generically at it and opened it up so that we could connect to remote machines, including Linux. So you can actually use this extension to talk to Linux boxes, including Raspberry Pis. And if we're lucky, I'll actually be able to show that. The network is challenging me today. And if you look up Azure IoT, you can find, after the ads, you can find a description of the Azure IoT suite and the Azure IoT hub. And so what you can, so the suite, as I was mentioning before, this is the part that is complete solutions, where they have things for, like I was mentioning, predictive maintenance is a big problem within the IoT space. Many people raise their hands for IoT. Would you agree with that statement? Somewhat? No? So are you guys consumer IoT, or people more on the industrial side?
A little bit of both.
A little bit of both? Okay. At any rate, so there's also the platform side for the Azure IoT Hub. And if you come in from this direction, they'll basically walk you through connecting a device up to Azure. And you can see that they kind of start you down the path of selecting the device that you're interested in, and then picking the platform that you're interested in. And this platform, the thing is, as you can see here, they have support for C, for C#, for JavaScript, for Java. They've got Node.js support, so they're very cross-platform. At its core, they have a C SDK that's available on GitHub as well. So you can go out there and take a look at that. And this is something that I was spending some time trying to bring up for a demo today, and unfortunately it's been not a good day for my demo food. But we'll see how far we can get. But basically you can come in here and you can see that they've got a complete C. This is where the C stuff is, so you can see that they've got, it's very well documented. There's walkthroughs for all sorts of different devices. There's porting guides on how you can get this to other platforms. And what this library enables you to do is it enables you to connect up to the Azure IoT Hub, which is designed for large-scale ingestion. So that thing's designed to have hundreds of thousands of devices pumping data up into it. So they have different size scale units that you can buy based on your needs in terms of how much data you're going to be throwing at it. There's also kind of a hobbyist size offering there. And if I can get in, oh look, it's going to actually let me use the creds I need. And so we come in here, we can see in the Azure portal that there's an option here for IoT hubs. I can then see the hubs that I've got. This is the one I've created. This is a free tier. You can create one hub that's on a free tier. And you can see that right now I've got 3 devices wired into it. This one's limited in terms of that you can only have 10 devices on it, and you can send about 8,000 messages a day. So it's enough to play around with and get familiar with it, but there's not a charge for this particular tier level. And so that connects back to all of this stuff that we're doing here. So the first thing we started looking at was what we could do with GDB and Linux. Now, I might have a serious problem here because I was not able to connect to that Pi from PuTTY. I'm assuming everybody here is familiar with PuTTY. If I can't find this Pi by its name or IP address, I'm not going to be able to deploy code and step through it, unfortunately. Instead, I will just have to show a little bit about what we've got. Yeah, I'm sorry. I can open up the project and show this, and then I can maybe, basically what this project is it's a little bit of C code that uses a library called wiring pi that basically just sets up access to the GPIO pins on the Raspberry Pi. From there, I basically just switch it. I could probably launch this app. I've got a serial cable connected here, so I've got to remember what system I'm on. I have to remember to ask sudo for permission a lot of the time. This thing does actually require sudo in order to access the GPIO, this library does. But basically all that this library did is, now that it's running, it basically just triggers the LEDs based on button pushes. And what I had hoped to show you was actually deploying that code from Visual Studio and stepping through and triggering the debugger at this point right here from a button press. I've got some videos. I can put up a page after the presentation to link to some other online materials where there's some videos that show some of this. But basically the way that this works, this is a makefile project type. And under the properties, if you come under debugging, what you'll see is we've got some different options here. I've got an option for a remote host name. I'm basically using external tools. So I basically set up what my SSH executable is, and I'm only supporting for this one using the certificate-based auth. So I need to set up SSH certificates and pass my key in with this. And then I can set what my remote directory is, my executable, and then how I actually want to invoke GDB on the other side. So basically this is just using it's opening up an SSH channel to the remote target, and then from there I can bind when I hit the debug. It will open up that SSH channel and go through there and issue the MI commands to drive GDB on the other side. And that, yes?
Could you try putting your IP in, maybe does it work with IP, or is it only, if you could try
It's
IP?
not even finding the IP.
Well, you had a serial cable connected, so I thought you might be able to, oh, it's not finding the IP.
Yeah, it's not finding any ping, unfortunately.
Just a quick question.
I've never done this over serial, so.
Are you running on the MSFP CorpNet or MSFP Open?
I have the Wi-Fi turned on in order to access the internet for those web pages, because when I first showed up here, I plugged in the cable and got onto the internet. The cable doesn't seem to be working for the internet right now. I've got both the Pi and a dongle for the Surface plugged into the same hub, which usually does it in order for them to find each other, but not having any luck with that right now. I believe it's on CorpNet.
I had trouble when my laptop was on CorpNet that my device was on Open.
Right. This particular laptop's not joined to CorpNet for power saving reasons.
There's an Android AP net sitting out there.
I don't have Wi-Fi on this Pi. But then from there, in order to actually get our code over to the other side, what I've got is basically just driving it via scripting. So because I've got those parameters on the debugging tab, I'm able to actually use them as part of scripts to drive PSCP and plink in order to actually invoke remote commands and copy files across. So it's a bit of a brute force, but it gets you there in terms of getting your stuff over onto the Linux side and being able to compile it. And just to give you an idea of how my day's been going, right there I had to, earlier today I found I was not able to debug, and it's because on my Pi I moved to GCC 4.9 for some other library that I was working with, and it turns out that that broke my debug capability when I was building this, and I had to go back to 4.6. So that's just the way that this day has been, unfortunately. And then if we go back to the debugging tab, something else I can show you here is we've actually got some other capabilities here. We can do local GDB. So for some reason you are working with something cross-platform that you wanted to compile, say with GCC and MSys or Sigwin, then you could use that here as well locally on your Windows system. And the last one, this one has not been released yet. This is something that should be coming out in time for build. But we've got a on-chip debugger as well. So I can bind to, if you guys, how many people here use OpenOCD? You familiar with that utility? Just one? Okay. What you can do, most of the on-chip debugger interfaces I've seen so far for the microcontrollers, if they have one either present on board or if you get an external device like a Seger, they actually present a GDB server interface. And so what we can do is use another, we can actually talk to that GDB server presented by the on-chip debugger interface. So there's an open source one called OpenOCD that we've been using with some success, the 0.9 version. There's another one called PyOCD that I've just started to take a look at. I have gotten this to work with Segers, but I'm not spending a lot of time looking at Segers right now. I don't know, how many of you guys are familiar with these little ST Nucleo boards? Cool, these are
We had a
$10.
presentation from, we had a presentation from ST Nucleo
Oh, awesome.
last year. Yeah.
Yeah, so I can actually hit debug points on this using this. And what's cool about these boards is they have the chip for the debugging interface actually on the board, so you can debug over USB.
Cool.
And that's also true for like the Arduino Zero board. They have the on-chip debugger here, so you can go over USB as well. So I know that there's still a lot of boards within the higher end of or the more professional side of the market that still have JTAG interfaces. My experience with them in terms of trying to set this up from you know, a broader view of Visual Studio was more and more dev boards I was seeing were coming with the on-chip debugger on the board. So I kind of backed away from trying to figure out the JTAG angle as much on the other boards because you'd get it working for one and then the next board there was some other config issue that it was difficult to sort through. And so I can close this off. How many of you guys have heard of something called Platform IO? Anybody? A little bit, maybe? This is a really interesting it's confusingly platformio.org. But basically, I don't know as much about their IDE that they just introduced, but they have a command line interface. And what this command line interface lets you do is actually create and drive embedded tool chains. So if we go through and take a look over here, we can go look at some of the boards that they have. And we can take a look at ST Micro, for example. Or actually, no, we don't need to do. And the board I have is the F1LE. So if we go and change source, after all that. We'll see if it's actually working in this one. Oh, you know, a reboot solves some problems. So what we can do is we can say Platform IO board, and there is the Nucleo, and this one is F411RE, and then I can do this cool thing here and say IDE, Visual Studio.
Boards up.
You know what it is? Actually, I forgot to say it in. Oh. So what this is going to do now, I haven't actually configured this board before here, and so it's actually going to go out and get the packages for me. So what's kind of cool about it is it will go out and get the platform tool chains for you for the various microcontrollers that you're working with. A lot of you said that you're working in embedded. How easy is it to find the tool chains that you need? Is it all right? Yeah? Do you have...
Depending on your wallet.
Yeah.
So but the open source ones aren't doing it, you really need the IAR and.
Actually, what I've been using is IAR for clients.
Yeah.
Or IAR and Kyle and Atomic are the ones I.
Oh, Atomic, yeah. So you can see what this thing does is it actually goes into my user directory. It sets up the packages here. So you can see the sort of frameworks that it downloads and the different tool chains that it downloads. So it downloads, like, for example, the ARM tool chain for you, which is kind of handy, and then it puts them all in this central location. So if I come back to Visual Studio, what I can show you is I have another solution that I was working on earlier today. And what this one does, I can find another USB cable. This one was for the Arduino Zero. But basically, this is just basically the blank sample. This particular project is not the one that was generated because I'm using the custom project system that I have from the GDB extension that I've got. And so what I did was I looked at what they generated for their preprocessor definitions and their include paths and basically moved them into my own here. This is something that I would look at, potentially working with them to try and contribute back to be able to generate this style of project files as well. But basically you can see that they've got all of the, includes for the framework and the platform so that you can work with the Arduino stuff right here within Visual Studio. And this is an example of how they build. So basically you're using this utility as your build system. So it's kind of a tool chain acquisition utility as well as a build runner, if you will. So this is something we've been looking at. And from there, what you can do is you can come in here and I can set what my debugger executable is. And from over here, what I would do is go into this guy and find find that guy here. Where is he? RGB. And then I would need to give it the. So this is the debugger server address. This is when you're running OpenOCD or your Seger client, then it presents a debugger GDB server. And so that's the address of the GDB server that you would give there. And then you would give your debug binary here. But for right now, I don't have any of that set up, unfortunately. And I don't know if we're going to be able to see how much of this mess I can hold up. If I get my Arduino plugged in here and make sure I'm on the right port. I can see it powered up here, but it's not showing up on the COM ports. All right, well, let me go and show another thing that we've got going on. So I mentioned that so far what we're doing, what I've shown you is stuff that we're trying to do to try and fill in some of the gaps on Visual Studio in terms of what sort of capabilities it has for the device side. I haven't really shown you anything about what we would do on the Azure side. I mentioned that there's a CSDK. Obviously, you'd be able to use the CSDK with any of the projects that I'm talking about here. But what would be nice is if we gave you something to actually help you get there. So if you search for Azure IoT in the Extension Manager, you'll find the connected service for Azure IoT Hub. And so I can download this guy and install it. And remember that I should have done this before because it's going to make me restart Visual Studio. So we'll close that instance. We can come back to that one if the Arduino shows up. So now that this has come back up, we can start a new project. we'll just take a look, we'll just do a, Windows console app. And now, if I go to my references within here, I can say add a connected service. And now I can add a connection to my Azure IoT Hub. And see whether or not it actually wants to call my phone as well as this. So you can see here, this is the same one I showed you before, which is my little free tier for the Azure IoT Hub. I can click Add. Oh, well, that's interesting. I'm going to have to see if I can find that later in my telemetry, because I have not seen that error before. See if we can, if it was transient. Interesting. I'm not having a good day, guys. What this would do, let me see if I actually bring one. Let me see if I can, let me disconnect the screen for a second and log on to my desktop. So what that should have done was it should have given me a list of the devices that I've configured, or let me add a new device. This is going to call my phone. Oh no, it didn't. The desktop is waking up. Oh, well, that's interesting. You can't change display topology during a remote connection. That's a new one on me. Let's try that again. All right, let's see if we've got it. All right, so what this has done is, this is the one that we actually completed. And so I had my console app, and basically, once it completed, it generated some extra files for me. What it did was it created this Azure IoT Hub CPP file. And what this has is it basically has a send a device to cloud message and a receive a message from cloud. So just these two simple messages that you can use in your app. So from my application code, it was as simple as just, sending that message to talk to the cloud and get a message up into the IoT Hub. All I needed to do was include the header file there, and then I'm able to use this. And it's fairly simple to understand in terms of where things are happening. So you can come in here and change the sort of stuff that you want to send in your message up to the cloud. But the trick of this is that it also generates your connection string. So it gives you the connection string that you need in order to actually connect to that specific device in the cloud. Now, obviously, for a production scenario, you would want to externalize that out from your application and have a way to flash those onto devices. We don't have anything right now to help you with that sort of stuff, but that's something I believe that the Azure team is working on in terms of what they're thinking about. But in terms of playing around with it today, it's pretty easy to get this set up and going. And then you can, from here, this code is fairly portable. If I can get back over to my Pi, because I did have this working on the Pi earlier today. take a look at this one. Basically, the only thing I changed to get this to compile on the Pi was I basically changed where the include paths were. So what that extension does in terms of working on Windows, for both C# or for C++, it'll download NuGet packages with the binary dependencies of the Azure IoT Hub. Obviously, we don't really have that capability on Unix today, but it gives you a quick iterative loop that you can work with this stuff on Windows and get things working there. And then you can bring it across over to the Linux side. And just by, we have some of the packages in apt, and we're working on improving that. But so it's a pretty quick way to just kind of get things working and trying things out. And so that's pretty much what I have to show you. I can tell you that in terms of future direction, what we're looking at I talked a little bit about the on-chip debugger. That's something that we're looking to release probably within the next couple weeks towards build. But it's very similar to the sort of capability you have now with the GDB extension. And the next thing that we're doing is the Linux. We're actually looking at breaking the Linux functionality out of this extension and improving it dramatically. What we're looking at doing is trying to actually drive the entire thing within Visual Studio. So basically our own SSH client within Visual Studio, so that we can do a better job of actually integrating with the Linux side and a better job of detecting when things have changed on the other side, incremental builds, stuff like that. As well as automatically pulling your library, your header files back across from the Linux side so that you can get your file set split up. So that's basically what I had to show you guys today. What sort of questions do you have? A lot of you said that you're working on IoT. Does this look like things that you would use? No? What do you use?
I use the native blockchain that I work with.
Okay.
So this looks like a lot of work. It won't get me any.
So what sort of tools do you use on the Linux side? Are you just using a VI, Emacs, or?
Yep, G-code.
Okay.
Well, okay, so I use SCP for my machine to make Linux bots to work remotely for my editor. And then I have a shell SSH window, and I use GCC and client.
So you're just driving it from the command line?
Yeah.
Okay. So what sort of things? So is there anything that we could do in order to? Well, I guess if you weren't even aware of Azure IoT, it's kind of hard to ask whether or not there's anything we could do to improve things there other than just make you aware of it, right? Are you connecting to cloud? Are you using a cloud today?
We actually use Azure in my company on a very large scale, and I'm not very happy with it, to tell the truth. But that's because the interface seems to be in flux.
Oh, okay. Which service are you using?
I don't know, I'm not kind of using.
Oh, okay. All right. Anybody else using clouds today? For your IoT devices?
Yeah, we're just starting the IoT part.
Okay. So are you in the process of selecting a cloud, or?
Yeah, I mean, we're trying to be agnostic, so we're
Uh-huh.
working with both AWS and Azure.
So are you looking at a solution that you're trying to make deployable in different customer environments and allow them to choose the cloud, or?
Yeah, so depending on the customer, if they want to go with AWS or Azure,
I
whatever
see.
they're comfortable with.
Okay. And so then you have to abstract away the entire cloud. Wow, okay. Yeah. And how many people here are using Linux? Yeah. Are most of you working natively on Linux, or? Yeah? Yeah.
So your comment earlier, what can be done to, make everything easier? Somehow automating this whole connection setup. I mean, every single project I do, A, it's different. B, it's finicky. C, it's usually poorly documented.
Yeah.
So like in the case if I'm using a Pi, for instance, I just load my entire dev system on the Pi and connect with VNC.
Yeah.
I call it done. Because you're usually not building something big there,
Mhm.
but, you know, especially with the current Pi, well, Pi 2, I haven't tried Pi 3 yet, which is even faster. It's good enough, you know, but by the time I go through all the rigmarole of connecting, I can just, you know, sudo apt-get my development system, done. But you're still taking a penalty from having the, you know, the connection to the Pi, working across a remoted interface and all that. If if it was simple to connect to and everything just hooked up, that would be a gain. But yeah, it's, you know, by the time you get a cross compiler onto the PC and remote everything across and get your connection, you know, and then remote GEB back, you know, it's a lot of goo that doesn't help a whole lot.
So
It doesn't get you, let's put it this way, all that goo doesn't get you enough benefit to not just remote into the thing and deal with a slower build.
Interesting. Okay, that makes sense. So, but that speaks to kind of a Linux machine where you can actually remote onto a small Linux device, and you can actually compile there.
Right.
But in terms of microcontrollers, you're stuck with cross-compiling, right?
Right.
Whether you're working on Linux or whether you're working on Windows.
Right.
But in this day and age, I mean, it's not that hard anymore to get Raspberry Pi and do all that.
Yeah.
And it's a really nice platform to get started and try things out and develop. And
Okay.
Sure, if I was doing something serious, then maybe I'll start thinking about cross-compiling.
And to address the topic of the smaller processors, you know, I was the guy that raised my hand for IAR and Atolic and those guys. And, you know, since these are, you know, commercial projects, it's, you know, somebody's there to pay the $3,000 a seat.
Right.
So that was something else you could do to get rid of that. But, you know, between those two solutions, that pretty well covers what I'm doing.
Okay.
And then, you know, sometimes I do use a cross-compiler too. I mean, the project I'm on now, we've got a cross-compiler. But again, it was a pain to set up. It disconnects and, you know.
Yeah. Does everybody pretty much agree with that in terms of, particularly with microcontrollers, that the cross-compiling, the tool chains are a problem? So that look right there, that, yeah, maybe, yeah, is that just because you just pay the 2-day penalty and then you're good for another year? Or-
Yeah.
Yeah,
Well, at least in my case, the problem isn't so much, like when it works, I mean, if you get lucky and it works, then yeah, like it's fine, you pay the 2-day penalty and you're good for a year.
Right.
What the worst scenario is when you follow the steps in the manual or in the documentation precisely, and it doesn't work, and it blows up with an error, and none of your coworkers have seen that error before, and like nobody knows what to do, and you're stuck for like a month, and you know, like you're just completely blocked.
I feel like I hit 3 of those today.
Yeah.
So, yeah.
Yeah, the stuff you were running into is totally typical of what we see day to day.
Yeah.
You just hit all of them in one afternoon.
And it continued when I got here. It was fantastic. I should have done slides. So, but so how many of you guys, so I've heard only a couple clouds. There were a lot more hands for IoT than clouds. So do you guys think you need a public cloud to be doing IoT?
Depends on what you're doing.
Yeah.
I mean, if you just have, you know, like just 1 or 2 devices, then no. I mean, even
Right.
with sensors, you're not going to be generating enough data to need a cloud. If you have thousands of devices, sure. Like if you're building, and selling a service, and you know your IoT is just, you know, your embedded device is just the front end to your actual service.
Yeah.
Then yeah, you're going to need, you know, some kind of cloud hosting, but then, you know, you can say that about any service.
So then so how many of you are just doing maker sort of stuff then? Okay. So, yeah.
The other thing is typically when I'm doing an embedded project, I don't have access to the internet to get to the cloud easily.
Oh, from the device.
Yes, from the device, because that's the whole point. Because if I I have good access to the internet, then I'll just use the computer. Whereas with the IoT things, I'm usually doing things where I want. I'm going to use a phone, like the phone system or something like that, or something a little different, or just connect through low power, low energy Bluetooth or something like that.
Yeah.
So a cloud interface for this sort of thing is not that useful necessarily for me, because again, when I'm able to get to the cloud, then I'll just do this on the computer or something a little more complicated. The whole point of going to embedded is low power and remoteness, and that's exactly when I can't get to the cloud. So,
Yeah. The other one I would tie into that is, even sometimes when you do have access to the cloud, it's through a cellular connection, because I've done one of those as well. And you're on a, what do they call it? Commercial machine-to-machine account, not like a normal cell service.
Yep.
It's a dedicated, those things are a nightmare on top of it. But you're being charged by the byte, essentially.
Yeah.
So extreme, and there, if you've got one thing, fine. If you've got N things, the extreme message efficiency of, very short, very condensed messages. So that's one thing that would, that'd be one of the first questions I'd come into with this is, how heavyweight are the messages going between the cloud and stuff? Because you guys are essentially, looks like charging by the message to some level. Where the...
Yeah, I'd say that's fair at some level. The scale, I don't remember the pricing on it, but the scale units are basically priced by a combination of number of devices and messages.
So from a consumer or from a developer, systems engineer or systems architect standpoint, I'm looking at a charge for Azure per message, and I would also be looking at a charge from the cellular provider per byte, and figuring out how those two add up.
and honestly, I've never built an end-to-end system. I've looked at it, and
They're a nightmare.
yeah, well,
Not because they have to be, just because of all the business stuff that goes into it.
right. But from the
Another word
computer
that's starting
to
with
the
B
cloud,
that I'd use.
Yeah.
The load is so tiny. I mean, we're talking Ks per day or something like that.
Yeah.
That's a lot.
Yes.
So that I can stick a 10-year-old computer on Wi-Fi in my house, and that'll add a ton of. I wouldn't, but I can really go for the cheapest cloud provider out there. I don't need much at all.
Right, yeah, I mean, it's...
Scale up is ridiculous.
Yeah, I mean, the thing is, I mean, yes, I don't think that, I mean, when you look at these sort of solutions, I mean, you can see even just by, these are the two, there's the free tier, which is really just for learning, how to use this. But I mean, when you've got tiers that, start at 400,000 messages a day, you're talking that this is a different animal, If you don't have that sort of load, then, you can feel free to roll your own or, use some other, a service that doesn't require, that doesn't have these sort of needs.
Wait a minute, so that's 400,000 messages per unit per day?
You know what, I don't know enough about that.
I was gonna say, I could see 400,000 messages per day for your entire system, but per unit, that's an insane update rate.
It all depends what you're doing. I mean,
It's like you have a network.
there's telemetry data that's coming in at once a second kind of rates,
Yeah.
and it's gonna add up fast.
Yeah, no, I can see that. I'm just
Yeah.
thinking that's at
I
least
can-
2 orders
I
of
can
magnitude above
follow
anything
up
I've
on
ever
that,
seen.
I honestly don't know.
I mean, in a way, this is interesting because it opens up new possibilities at that scale, but
Yeah.
it's not where I'm playing it.
Right, yeah, no, if you're doing hobby projects, then no, this is not,
Yeah.
yeah.
Well, and most of the ones I've done, we were updating, one message a minute type of thing.
Yeah,
And that message was, I don't know, 50 bytes tops.
yeah.
And because it was a machine, that was more than a sufficient update rate.
And so what do you need in terms of data formats? I mean, do you always just roll your own data format?
Specifically because of the efficiency. I mean, if you're paying for a cellular connection where you've got a very low data load, your data is expensive, let's put it that way, however you want to
Yeah.
measure it.
And it's not just expensive in terms of money, but it's also expensive in terms of electricity. If you have
Yes.
an embedded device that's going to be running on battery power,
Yep.
then it behooves you to do all you can to make sure that that radio is on for as short a time as possible.
Yep.
Yeah. And so what sort of processors are you working with in the professional solutions you're working on? Is it primarily ARM these days?
ARM, STM, and actually PLCs. So where you don't care what in that case we had a dedicated M2M, essentially router that has a cellular connection chip, or a cellular connection and a SIM chip in it. We had our own little network inside the device.
I had a question about the GDB stuff.
Yeah, sure.
Is this complete? Is the MI interface complete? As in, like, I could replay this. Let's say I didn't want to use Visual Studio. I do, but are the messages like? Is there like a debug log? I wanted to see if there's other editors, for example, if you could do it from Emacs or Win, but on Windows, because I don't like using Linux as my main developer machine, but I do have needs to actually get it on there.
So, I don't know. The MI engine here, it's open source. It's out there. I know that if anybody were to try and integrate this with a different editor, I'm sure the team would love to hear about that and work with somebody who's looking at something like that. It's probably feasible, but I don't know. And I don't know how complete it is in terms of all of the machine interface. I mean, they've got it fairly well documented here. In terms of using it within Visual Studio, debugging over Linux, we haven't hit too many things that weren't supported. The only one I can think, the only customer ask I've had of something that wasn't supported was child process debugging. That just wasn't bound from the machine interface into Visual Studio's child process debugger. But that's something we're looking at addressing. So it's not something that's not possible. It just that was a gap in terms of what we had. But in terms of the MI interface itself, I really can't talk to them. If you give me your contact info, I can definitely hook you up with these guys if you want to ask them directly. Yeah.
So here's another dimension for you to think about. How compatible is this with all being set up inside of a virtual machine? So one of the paradigms I use when I'm working with a team, specifically because setting up these tool chains and everything around it, your entire development environment. I mean, we've spent up to a week, sometimes setting up just the environment. I've typically gone to one person sets it up, and this is on a Linux scenario, places it, the whole thing in a virtual machine, removes all the login and riffraff, and then we just distribute that virtual machine to the entire team.
Interesting.
And now everybody, A, doesn't have to do it, and B, is using exactly the same thing. And one of the scenarios we run into with a Windows environment when we're working on it is some of the licensing restrictions and stuff adds A, extra headaches, or B, just simply forbids that. So it's one of the paradigms we've run into.
Interesting.
You could do a
Windows
Windows.
licensing is Windows licensing. I don't know.
Yeah, I'd have to go back and look at it again. It's been a while since I looked at that. But that's one of the scenarios under Linux that really helps team productivity is being able to have one person, typically the expert, get all this stuff set up and working, and now extremely easily distribute that to as many people on the team.
We have, I know that we've got VMs in Azure that are pre-configured with Visual Studio, including different editions of Visual Studio.
Yeah.
I don't know what the capability there is for you to say, do something similar to that, and creating your own VM image and then uploading it. What would happen with the licenses? I'd have to ask around about that.
Yeah, I suspect that at least when I've looked at it in depth before, it was more problematic. I don't know if it was completely impossible, but it was more problematic.
It doesn't sound like it would be impossible.
And
I'm just not sure what tools we have that would help enable this.
right, and the other thing I use that for is, sometimes I'm in my home office, sometimes I'm on the road. I take one VM and it goes back and forth between my desktop and laptop.
Yeah.
And, so that's easier licensing,
Mhm.
because you're not moving between people.
Right.
But it's something to consider and all that, because it's a technique I've found very, very helpful for, team
Yeah.
consistency and team productivity.
Mhm. What about build servers?
Typically, the builds, I've played with those a little bit, but sometimes you're in the field, and you may or may not have network connectivity, so you just can't rely on
Interesting.
the connectivity. You need to be
Yeah.
able to put everything on your laptop and take it with you.
Yeah,
At least for sometimes. I mean, sometimes if you're in the office, that's fine.
right, yeah. Is it important to maintain, I mean, you talked about among the team, and that makes sense in the development phase, but in terms of release, when you're actually releasing the binaries, I mean, are you flashing hundreds or thousands of devices?
Depends on the project. Sometimes it's 1, sometimes it's 5, sometimes it's 100,000.
Uh-huh.
I've seen all those scenarios.
How important is it to keep control of knowing exactly what versions of libraries and compilers you use when you're
Absolutely. 'Cause that was the other thing I was going to mention. I generally work as a consultant,
Uh-huh.
so when the project is done,
Mhm.
that VM becomes archived,
Okay.
and that goes on to a long-term storage system.
Mhm.
And so if it ever comes up again,
Mhm.
you can go back to exactly what you were
Yeah.
using, regardless of any automatic updates or other riffraff that may have happened in the 2 years that passed.
And then the VM, by doing it that way, if you have a situation where you have to deploy into the field in order to update some firmware, you've got that advantage as well.
Yeah, exactly. And the other thing is when you go to try something new, like just what happened to you today.
Yeah, right.
I'm going to try this new library.
Yeah.
Okay, set a not a recovery point, a snapshot image on the VM, try it. Oh gee, it failed.
Yep,
Revert, and I mean it's
Mhm.
seconds.
right.
And and it's not only seconds, you're guaranteed of what you're at. I mean, it's even, you have an exact image of where you diverted.
Yeah.
And that's, just knowing that's the way it is really reassuring. So yeah, I find VMs are very, very helpful in this type of development.
Yeah.
In that scenario, have you looked at trying or considered like container technologies, like Docker, which is also kind of Windows?
You asking me?
Well, I had a question from the room. He's talking about being
Yeah,
able to take this environment portably.
Personally, I'm aware of the container stuff. I haven't used it very much myself. So it's kind of on the perpetual backlog of things that I need to get to and look at. It seems like it has a place in this world, but I have not had a chance to spin up and understand it well enough.
I think if that could be made viable and be available on Windows and on Linux, that can sidestep the licensing issue for Windows.
Have you seen Resin.io? Resin.io is this is one I've not looked at closely myself yet either, but it's just another of the many things on the backlog to understand. But this is basically a container solution for Linux IoT devices. So very.
Really, really scary.
What's scary about it?
It's security hole for your device to be I want to be very, very careful about how that works because we have used Docker and now we use LXD dump Docker because the security issue is ridiculous.
Were the security issues and lack of trust in terms of where the packages were coming from that were in the images? Or?
No, it was lack of trust in Docker itself and not a good feeling about how they act around some of the issues that were there. Again, I'm not the expert on it. We have a guy it's like you said, we have a guy who develops containers for us and we just all use it. We're not using LXD. I think they're much, much cleaner.
Yeah.
But he was very unhappy and he's an expert. So I trust him,
Yeah.
basically. But anytime you have to update your device over the air, that to me is basically a huge security hole in your device.
Yeah.
So it's a little scary. That's why I say it's scary.
So with not having an update mechanism.
Yes,
Yeah.
exactly. Yeah, I don't, it's the, I don't know that I feel that update over the air is the security hole. I think it's, you know, there's potential holes whether or not you update over the air. Ask some of the devices in my house. You know, once you open them, you can do what you want with them. Yeah. Okay, anything else? I think that's what I've got for you. I will send you a link. I'll take and put together a page with references to everything I brought up tonight. And I'll try and get some of the samples posted as well that I showed.
Yeah, go ahead and send that to me, and then I can get it up on the website, or
Yeah, sure.
Rohit can get it up on the
Yep.
website.
Okay.
Actually, no, it might be you, because I'm gonna be gone for a bit
Yeah,
again.
that's fine.
We'll
And
get it handled.
Yeah, it'll probably be about a week because I've got a lot of stuff going on in terms of preparation for build right now, so. Okay.
Cool.
Cool. All right, thank you.